Hello, hello, hello. Am I live? Hello. Okay, I can see myself and also here. So audio level should be fine. I will just start with this problem, palindrome partitioning part 3. That's where we left yesterday. I was going to solve it today. Let's solve it. Is everything visible? Yeah. Mhm. Oh, need to remove this. Okay, fine. We are given a string S containing lowercase letters and an integer k. You need to first change some characters of S to other lowercase English letters. That sorry. Then divide S into k non-empty disjoint substrings such that each substring is a palindrome. And number of characters that you need to change to divide the string. Okay, and this is the start length. Now we'll form all the different, what do you call it? All ha, will form all the different palindromes of all the lengths, right? So I kind of forgot this part from where it starts. I know it is from J minus I, no, minus length plus 1 or something like that. Should be less than n, but I need to check how did they initialize it. Okay. Int I starts from 0 to length minus 1. It should be less than n. And j is I plus, yeah, then minus 1. Okay, so int I equal to 0, I less than, no, I plus len minus 1 should be less than n. I plus plus int j equal to, what is j? Um, I plus len minus 1, right? Now, int, not int, this is not dp, right? This is palindrome. Number. New int This will be of size n. Palindrome of I comma j is equal to palindrome of I plus 1 j minus 1 plus if s dot char at this is equal to s dot char at j, then return 0, else we add 1 because there is a difference between them, right? That's how we create our palindrome uh, checker of from different lengths of basically different substrings. Now we need to write a function, right? Let's call it DFS and make this a global variable. Okay. We send S, we send K, public int DFS, string S int K. We have I. What is I? At that position, um, yeah, I is basically that current index position, right? So if K equal to 1, then it means that we have successfully made all the partitions. So return, do we also need a G? Now return DP, should we return DP or the minimum number of characters I need to change. This will be for int j equal to I, j less than n, j plus plus. If did we return cost? Okay, from return palindrome from I till from this index till the last index. So do we start from s dot length? So we start from 0 only. But from that index, when we reach this condition, we'll be at the end, right? From that index to the end. Okay. Mm, And this here we compare int answer equal to major max value math dot minimum value of answer and this will be palindrome of I till j plus plus I have calculated till here. Now from this point move ahead and give me the solution for that. So I have calculated till this point, starting from this up till this point. Now what we want is from this point to the end, return that cost. So we'll call DFS again as k minus 1 because we have already made this partition, k minus 1, and I this will be j plus 1. Is this right? Yeah, I plus 1. Oh, I plus 1. Yeah. This is basically j for us. Yeah, this is, yeah, perfect. Hmm. This is a difficult problem, not gonna lie. This condition is a bit tricky. I explain this condition. Explain this base case condition in detail. And then understand why they are a problem. This that is till that is they why is the second uh state is not then minus I mean I just got it why. Okay. This is when k is equal to 2. We call this function and k becomes equal to 1. Now we have a single partition, right? Now to what is the cost to change the characters inside this substring from which is from I to the end because we have only one partition left. So yeah, this makes sense. I mean, just wait it down. We must okay. Now it's just that I have to memorize this code. Maybe to make this and for that is for AP of I with minus if dp of I comma g is not equal to -1, return this. Oh, is it k? No, yeah, it should be. Yeah, it should be. Where did we memorize? Yeah, this is still K. Yep. Oops, this is K. Because include that K. So, okay. Mm, okay. And what? Oh, I J starts S dot length minus K. Why did it do minus K? Why did it subtract with K? What? Oh, I don't use string here. Okay. Yeah. Oh, return there. Oh, that's it, right? Yep. Okay, this problem's done. Palindrome partitioning. Part 4. Let's solve this first. Given the string return true if the S can be palindrome after deleting at most one character from it. I think I can solve it in using a stack, right? Two pointer string really. Two pointers. Like we have this, we have here, and now we found one mismatch. Int n equal to s dot length for int I equal to 0, I less than n plus plus uh, char ch equal to s dot char at this. Wait. Instead, I can just run a for loop while, oh, I mean a while loop, while L is less than R. This is the character at the left position. This is the character at the right position. Okay, this is left character, right character. Should I just directly write those conditions? If this is not equal to this, then what should we do? Then we need to check if if S dot char at L plus 1 is equal to S dot char at uh, S dot char at R. If this is true, then L plus plus, else if, no, and now what we do is create a boolean that's named use. As of now, we have not used this. If this is not equal to true, then used becomes equal to true. If use is already true, then return false. If s dot char at l equal to s dot char at r minus 1, then r minus minus used equal to true, right? This should be else if. Oops, return true. No. Oh, my bad. Oh, it's 10 power 5. Okay. Should I just do this? CH. No. Let me ask, why is this given particularly first? Why is this in really? Pointers don't always move on mismatch. Okay, here else return false. Yeah, that's it, right? Let's add this test case. Okay, let's see. Intake pass. Okay, this is like a very brute force approach, but yeah, these will be these will see what ChatGPT says. If I have chopped my personal whole mirror and hmm, your experience. Alright, let's select so, okay, so I need to write a function with this value only string is int and while this system if is will is not equal to description are then return false. Otherwise, return if the characters are not same, return is valid. So is we have L plus one and R or is one. Why is this or? If both are zero, I mean false, then return false, right? Why did you use or we can this mean we can use right. So only so if only one return false in the string, it is um, um, if the string can be after deleting at least one character. That means you are not allowed to delete zero or one character. You only need one valid way to succeed. But if in the future, okay, if this returns false but this returns true, we move ahead. But in the future, again, if this returns false and this returns true, we cannot move ahead, right? Oh. Hmm. Okay, okay. I kind of understand. Like, if, uh, hmm, okay, because we have already checked up till this point. We just need to check for this. Okay. Okay. Okay, I understand this. Okay, basically what they are trying to do is we have bunch of characters. Yeah, never mind. We check if this and this is a palindrome or not. If this or this, yes, they are a palindrome, right? Now, let's say, okay, let's say we have checked this. Now move on and let's see if this and this is a palindrome. Yes, it is. We move ahead. We check if this and this is a palindrome or not. It is, right? So we already know that, okay, we know that up till this point, we have a palindrome. Now, here we have a mismatch. Here we have a mismatch, right? So just check if if even if we skip this and check from here to here whether or not this is a palindrome or not, and if we skip this, check from here to here whether this is a palindrome or not. If any one of them returns true, then yes, you have a palindrome. If both of them returns false, then we don't have a palindrome. Yeah, because this is already checked. This is already checked. We don't need to check this again. We just need to check from this point to this point and from this point to this point. Okay, we directly check if it is a palindrome or not. Okay, yeah, this makes sense. Let's submit this code. Let's go. Okay, let's solve the partition from partition part 4. Then we'll move on to next problems. Oh my god. Anyways, given a string is returned true if it is possible to split the string into three non-empty palindromic substrings, otherwise return false. Do I have to write the bottoms up only? I guess I cannot write. Okay, now we can memorize the code, so it will be n square and into 3. So n square into 3 is basically not into 3. And this will be n cube 2000 into 2000 into 2000. 15789. Oh, no. This one. Because this is n cube basically. 23. Should I say, let's write the code first. Let's see. Let's go and equal to this. Then, ah, into probably in Boolean DFS. Do we need the divide split this into three non-multiple sections? We do want S, we want RK if K equal to 1, return into into if palindrome of I comma k minus 1, and then I can s dot length of rather n minus 1. Yeah, for int length equal to 2, length less than equal to n, then plus plus for int I equal to 0, I plus len minus 1 is less than n I plus plus into j equal to this palindrome of I comma j equal to palindrome of I plus 1 j minus 1 plus s dot minus I if it's equal to s dot I. No, this is not plus, this should be, and then if this is true, then return true, else false. If this character is true and this character is also true, then return true, else return false. This makes sense. Now return DFS of S, I, and K. Let's what is K? K is 3. I will start from 0. We have S here. Okay. For int j equal to I, j is less than equal to n minus k, j plus plus. Okay. Now return If palindrome of I till j is true and DFS of I plus 1 k minus 1, I don't even need the string here. This is true. Return this, right? What else do you need? What? Oh, yeah, I thought so. Hmm. Initially, this will be set to false. Return I will come back. Need to go to the washroom. I will be back soon. Fake to okay, back. It's and also your substrings made this partition k minus 1 and I this will be j plus 1. Is this right? Basically, not into 3. Yeah, okay, so my audio is good. Okay, back. Okay. The audio levels are good. Perfect. Now, why is this wrong? Let's see. Okay, if this is true, directly return true. Ah, why can I now do this? Um, oh, J plus 1. Did I do I plus? Oh my god. It's J plus 1, of course. Bye bye. Oh, oh, if this is true, if length equal to true, then otherwise palindrome. Okay, so this is just if length equal to 2 or just return palindrome of I plus 1 j minus 1. That's it, right? Yeah, and rest should be fine. Arif palindrome. Fine. Oh, do this only if the characters are matching, of course. This works. Captain S dot char at J. Oh, Palin from new Boolean and cross. And okay, that's it, right? Yeah, okay. Why did the skip false? This one. Oh, okay, initialize this first. Measured by equal to 0. Less than this. Like a rule for cooking. And then palindrome of I and stick. Yeah, okay. Strong recursion in IR, it's reduced plus one. Okay. As soon as you get a valid palindrome, just return true, right? But if you never find this, then return false. So here the return true. and here it becomes false. Now this code can be memorized, right? I do want this version. Let's write code for BP, TP, equal to new Boolean. This is n. This is 3 plus 1. Okay. Now, for entire to the wireless this my raise dot fill. This will be TP to 5. So stop. If BP of I and K, if this is set to true, then return this. Otherwise, just store it. I will need to memorize this code. Hmm, What operation? Array. Will this Fine. Oh wait, I didn't initialize. Oh, this will be set to false, right? Initially, so the relay DP. But does memorizing this code mean mm, mm, Yeah. So I don't even need to memorize this code. I don't think so. I think I don't need to memorize this code. This should pass, right? It's a open square. Yes, I did. Defense. Okay. Should I try the bottoms up approach like solutions? Right. That's right. Um, s- Okay, so we do need this. Let's convert this code into bottoms up solution. We do need all of this. Palindrome of 0 to I is false. Hmm. I equal to 0, I less than n minus 2. Three partitions, right? Huh. This will be the next step. Okay. Now, if palindrome of I comma j, if k equals to 1, we can palindrome. I understood this condition, but then like this one, explore all the different possibilities. If palindrome of I plus 1, okay, I plus 1, lj, and j plus 1 till n minus 1. This is true. 22. What equal to I plus 1 plus 1. divided to I plus 1 and j equal to plus 1 in the for loop and not start from I, j equal to I. Like because cell is also a palindrome, right? J is basically the split. So you get this one to J and then just okay. So if palindrome of I to J is not J from 0 to I. If this is not a palindrome, then just continue and find when we find and continue till we find a palindrome from 0 to I. Now that we have a palindrome from 0 to I, we just need to find two other partitions. So in j equal to I plus 1, j less than n, j plus plus from if palindrome of I plus 1 till j. From this till j and palindrome of j plus 1 till n minus 1. If this is true, return directly return true, else return false. This should work. We don't need this. We don't need this. Okay, so it should be outside. No. Oh, less than n minus 1. Hmm. Wait, got accepted. Wait, is copy this. Evaluation. Wait, mm, wait, um, relation, wait, push, opens, mhm, mhm, well, I was going to solve this problem. Longest common prefix. I actually want to see the solution because this doesn't look like an easy problem. So, correct. Let's search it on YouTube. Mm.
Just a minute.
There are many. We are looking 9
Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem longest common prefix. We're given a list of strings and among all of these strings we want to return whatever is the longest common prefix. Now what is a prefix? Well, it's just a portion of the string. So for example, this string flight, a prefix is just any portion of the string starting from the beginning. So F is a prefix, FL is a prefix, FLI is a prefix, flight itself, the string itself is a prefix as long as it starts from the beginning and is continuous, then it's a prefix. And we want to return the longest common prefix among all of these strings. So, what's the intuitive way to tackle this problem? Well, look at the beginning, right? All three of these strings start with an F, right? So F is a common prefix among all of these strings. Let's look at the next character, L. L is the second character in all of the strings. So another prefix that's common among all the strings is FL. Now let's look at the third character. O is the third character in this string, O is the third character in this string, and I is the third character in this string. So unfortunately, FLO is not common to all three of the strings. It's common to these two, but it's not common to this one. So FL is going to be the longest common prefix that we have, so that's what we can return. So the problem really is that simple, but there are a couple edge cases that can trip you up if you are a beginner. So we're going to be focusing on that, especially when we code it up. So basically, we are going to simultaneously iterate through all of the strings that we're given. One of the strings could be shorter than the other string. So for example, if we weren't even looking at this string, we can see that these two strings, this string and this string, they both start with flow, right? So flow is a common prefix to both of these two strings. Then if we got to the fifth character, we'd see that, okay, E is the fifth character here. This string does not even have a fifth character, right? So if we get out of bounds out of one of the strings, then we know we can stop, right? And that makes sense, right? Flow would be the longest common prefix among these two strings. So what's going to be the time complexity of this solution? Well, potentially we're going to have to go through every single character of every single string string, that would basically be the case if, we had, let's say we had flower and we had it multiple times, right? Then we'd have to potentially iterate through each of those flower strings, right? Because they're common, so we wouldn't stop. And then we have to go through every single character. So the overall time complexity, let's say, is going to be n, where n is the total number of characters that we're given. Or if you want to say that n is the average size of the string, and we have m different strings, then you could say this is the time complexity, right? However you want to formulate it. But overall, we're going to just have to iterate through each character in the entire input once. With that said, we're ready to code it up. So the first thing we're going to do is initialize our result. Remember, if let's say we didn't even have a common prefix among any of the strings, right? They all started with a different character. Like we had A, we had B, empty string, because there is no common prefix, right, through all of the strings, right? So we're going to use a pointer I to indicate what index that we're at in the strings. And we're going to go through, let's say, through every single character of, let's say, the first string, right? I'm just putting the first string here, strings at index 0. This is just the first string. I'm using that arbitrarily, right? Because it could be possible that this string is not the shortest string in the input, right? In which case we'd want to stop this for loop earlier than it's actually shown right now. So we'll have to remember to handle that case. I'll handle it slightly differently than using a conditional out here. So, okay, so we're iterating through every index. We want to now iterate through every single string and make sure all of the strings have the exact same character. Now, if string is first string, right? I'm I to indicate what index that we're at. Every single character of, let's say, the first string, right? I'm just putting the first string here, strings at index 0. This is just the first string. I'm using that arbitrarily, right? Because it could be possible that this string is not the shortest string in the input, right? In which case we'd want to stop this for loop earlier than it's actually shown right now. So we'll have to remember to handle that case. I'll handle it slightly differently than using a conditional out here. So, okay, so we're iterating through every index. We want to now iterate through every single string and make sure all the strings have the exact same character at index I. So let's go through every single string. So for S in the list of strings that we're given, we want to check that every single string at index I is the same. So let's compare this arbitrary string S to the first character of the first string, right? We could pick any of them, but we just want to make sure that they're all the same. So we'll just make sure to choose the same one every time. So we'll go to the first string, right? Strings at index 0 is the first string in the input, and then we'll go to index I of that string. So as long as they're equal, we're going to continue. If they're not equal, though, which is this case, then we're going to have to return, right? We're going to have to return whatever our result is so far, because we know that whatever this prefix is, that's going to be the result, because we can't make the longest common prefix any longer. But there's one case that we didn't think about. What if we went out of bounds, right? What if this string S is out of bounds? Because we know this is going to be in bounds because that's our I pointer up above, right? I is always going to be in bounds of the first string because that's what we're iterating through up over here. But this string might go out of bounds. So before we check this condition, we're going to make sure that I is in bounds. So we're going to say that if I is equal to length of S, which means it's out of bounds, right? Then we're going to also return, right? We're not even going to check this line of code. If this evaluates to true, we'll check the second. Remember, every time we go through a character, we want to add it to our result. So we can do that pretty easily like this. We can go ahead and add that character that is common among all the strings to our result. And then once we're done with all that, we can go ahead and return the output result and we'll be good to go. So I'll run it to make sure that it works. And as you can see up above, yes, it works and it is pretty efficient. So I hope that this was helpful. If it was, please like.
Okay. Start from the first character. Is null or this return this. Yeah. If str is, if this is null, or if the str is for length, if this is equal to 0, return this. Now for int I equal to 0, I less than n, I plus plus. Right now, this character car wait. STRS zeroth character can add I for int j equal to 1, j less than n, j plus plus if strs of j dot char at wait what hmm, dot char at I is not equal to rch, or if I is equal to strs dot length strs of j dot length or this, then return skrs of 0 dot substring 0 to I, else continue, otherwise return strs of 0, etc. Oh yeah, this is a array. Okay. On 0. Oh, strs of 0 dot length. Okay. Oh, why am I laughing? Wait, hello. Why am I laughing so much? What? Okay, anyways. I'll eat some lunch and will be back. Then take to black.